Right, so the first question we're going to take a look at is describing or listing transformations for a radical function. So we're going to be comparing this one to that one. So the first thing is to just figure out how many transformations you think we have in this problem.
3.
Yep, so we have 3. So remember, when you're solving or writing the transformations, you always start out with what's inside the radical first, and then just kind of work your way out. So we're going to start with the plus 5. Okay. Do either one of you remember what the plus 5 is going to do?
Shift to left 5.
Yeah, that's when you have plus, that's going to shift it left 5. So start with that. Shift left 5. Michaela, what about the 2 on the outside? Is that vertical or horizontal?
It's vertical.
It's going to be vertical. And is it a stretch or a shift?
A stretch.
That's a stretch because you're multiplying and it's on the outside. Any multiplying is a stretch. Outside is vertical, inside is horizontal. I didn't do a horizontal stretch in this one. So we say vertical stretch by factor of 2. And the last thing is going to be the minus 4. What's the minus 4 going to do?
Shift down.
And how many? Yep, so shift down 4. So when I ask about describing the transformations of radicals, that's pretty much what you have to do.
Okay.
Remember that when you describe the how much part, like left 5 by a factor of 2, down 4, the how much part is always a number. Okay? It's always a number.
Are we learning anything new tomorrow?
Tomorrow is review. Yeah,
All right.
we're going to review what we did today, like we did Tuesday.
All right.
Any question on that one? All right. All right, so the second one we're going to look at is solving a radical equation. So the first thing I mentioned, you always want to make sure that the radical is by itself on one side. Is the radical by itself in this one?
Yes.
Yeah. An example where it wouldn't be is if you had that. Like if you had 3 times the radical, now it's not alone. How would you get rid of that 3?
Divide by 12. Divided by 12 on the other side.
Divide each side by 3. Yeah. Yep. And then you'd have the square root of x minus 4 equals 12 divided by 3, which would be 4. But in this case, we don't have anything outside it, so the first step is already done. So now the next step is to get rid of this radical symbol. What kind of radical symbol is that?
Where you just square it.
That's a square root, yeah. So how do you get rid of a square root?
You square.
You square it. So you have to square this side and square that side. When you square what's on the left, the square and the square root cancel. And what are you left with on the left side?
X minus 4.
X minus 4. And on the right side?
6. Or no.
So 12 squared, so 12 times 12.
144.
144. And now the last step to get x alone, we just got to get rid of the minus 4 by doing a...
Adding 4 to the other side.
Yeah, we'll do plus 4 on both sides. And what does that give you for x?
148.
48. Okay, let's check it, make sure it works. If you take 148 and plug it in, what's 148 minus 4?
144.
144. And what's the square root of 144?
12.
12. And that's exactly what we have. So that works. Okay, any question on that one? Okay, so this one, a little different than the other radical one. They're not asking us to list the transformations. They're asking us to describe a few different things. The first thing is the domain. So I've written the function 2 plus the square root of 3x minus 4. Whether you put the 2 plus in the beginning or the plus 2 at the end, it's the same thing. Okay, now when we take a square root, we can only take a square root of what kind of numbers?
Positive numbers.
Positive numbers or 0. So that means we need to make sure that 3x minus 4 is always 0 or higher. So what symbol would mean 0, or what symbol would mean a number or higher? Greater than or equal to. That's how you find the domain. We can graph it too, and I think we did some graphs in class, but we just want to make sure that this number is at least 0. So that's how we can do it. How would we get the x by itself there?
Add 4.
I think this is probably faster than graphing it.
Yeah, and divide it.
And divide by 3. So x has to be at least 4/3. And that's the domain. Which again, you can get by graphing it as well. But that's how you do it. Now the y-intercept. Let me just move these down a little bit. Okay, the y-intercept. That's when you plug in 0. Do you remember for what letter?
0, 4.
Think about if you had a graph like this. That's your y-intercept right there. Think about which part of that coordinate would have a 0.
Okay.
The x would have a 0. Yeah. I don't know what the y is. But to find the y-intercept, I know x is 0. Okay, so let's plug in 0 for x and see what happens. All right. All right, now let's see what happens. What's 3 times 0?
So is it always just like it's just going to be if there's a number on the outside? Because it's always going to cancel out basically? You're going to have to times it or no?
Nope.
It's not always just going to cancel out?
Nope.
0?
That's not what's going to happen here. What's 3 times 0?
0.
0. What's 0 minus 4?
Negative 4.
And what's the square root of negative 4?
So if it's just like 3x on the inside, if there's no number, then it would?
That would
there's
have been
plus
okay.
4 there. That's how it would be. Because we didn't want it in class and it just canceled out to 0 because there was no plus 4 or minus 4.
Well, we weren't plugging in. We were setting the radicand equal to 0. We're going to do that next.
Okay.
So this is a little different. We're not setting it equal to 0. We're filling in 0.
Okay.
So when you fill in 0, you get 3 times 0 is 0. Minus 4 is negative 4. And what's the square root of negative 4?
Non-real number.
It's a non-real answer, which means it's what kind of answer?
Imaginary.
Imaginary. There is no y-intercept in this problem. So I meant to write NA. This graph will never cross the y-axis. What does that mean? Maybe it looks like this. And it curves that way. Never crosses the y-axis. Now, it's a square root. Do square roots have a start point or a center point?
Start.
Yes. Now, let's do what you had just said. You talked about finding it. So, when we find a coordinate, it has 2 parts, right? It's got the x and the y. How do you find the x value of your start point?
So y. Set it equal to 0. Right?
You set something equal to 0. What?
Set whatever under the square root is equal to 0?
Yes. Set 3x minus 4 equal to 0. And we kind of had to just do this when we found the domain. So we're kind of doing the same thing again. But instead of greater than or equal to, now we're just saying equal to. So you add 4. And what does x equal in this case? 4/3. So that's the x value of your start point. So the start point is going to be 4/3, comma. Well, let's plug that back in, and now it's going to be what you said. If you plug in 4/3, what's 4/3 times 3? Or think of it this way. What's 4 divided by 3 times 3?
4 divided by 3.
Divide by 3 and then times by 3.
4.
You're just going to get 4. It just cancels out.
Cancel that, yeah.
And then 4 minus 4,
0.
0. And the square root of 0,
0.
0. And then plus 2. So your y value is 2. That's the coordinates of the start point. Now, the direction is, I want to know which way the graph is going to go. It's either going to curve to the right, to the left, or it goes in both directions. Well, it's a square root. Do square roots go in both directions?
No.
No, that's an odd root, so it's not both. What's the direction that a root normally goes in?
Right.
It normally curves to the right, like that. The only way it could curve to the left is if you reflect it horizontally. Are there any reflections in that problem?
No.
No. That 3 would have to be a negative to make it curve to the left. So this one curves to the right. And there'll be a couple questions on the test pretty similar to that. Where
If
I
you
ask
had
you,
it as like that 2 up there, instead of having it plus 2, if you had it times 2 and that was negative, would it reflect like underneath? And then it'd be
like if you had something like this,
times, Would that be now underneath and going opposite?
yeah. So now it would, instead of being like in quadrant 1,
Yeah.
it would be down in quadrant 4. Yeah, it would reflect like that. Yeah. So it can reflect 4 different ways. That's the 4 ways it could look. Horizontal, vertical, and then both horizontal and vertical at the same time. All right. So any questions on the y-intercept, direction, start, or the domain? Okay. Okay, so the next one is solving a rational equation. So that's that topic. And it's one that is doable algebraically. So what we want to do is get rid of all our denominators. So we're going to multiply all 3 of these by the least common denominator. Let's check what happens if we multiply x plus 2 and x minus 1, and let's make sure it's x squared plus x minus 2. Just check it. What's x times x?
X squared.
And then x times negative 1,
Negative 1.
and x times 2,
Yeah.
and 2 times negative 1.
Negative 2.
If you combine like terms there, do you get what's on the other side?
Yeah.
Yes.
So this denominator is the product of these 2.
If it's not that case, you can't do it algebraically.
If it's asking you to do it algebraically, it will be that
It will
case.
be that case.
Yeah, it won't. It's not that you couldn't do it, but these are the ones that we did.
Okay.
So it'll be like that. All right. So what could we multiply all 3 of those by that would cancel all my denominators?
X plus 2 and x minus 1.
Yes. So x plus 2, x minus 1 in all 3 spots. Now, before you do anything, you want to cancel whatever you can. And what cancels out in the first fraction?
X plus 2.
Yep. All right. What cancels out in the second fraction?
X minus 1.
X minus 1. And the third fraction?
The bottom.
The whole thing. So what does that leave me with on the right side?
5.
Just 5. Yep. Now on the left side, we've got to distribute out whatever we have left. So we got to do 3x times x minus 1. Okay, so we got 5 on the right. And what do you get if you distribute 3x to x minus 1?
3x squared minus 3x.
It's 3x. Now the next thing you're distributing, make sure you grab that sign with that number. It's positive 2. Just like that.
So 2x plus 4.
So plus 2x plus 4. And the highest exponent on the left-hand side is a square, which makes it what kind of equation?
Quadratic.
It makes it a quadratic. So we eventually want to get it equal to what number?
0.
We want it equal to 0. Yep. Okay, so combine like terms. What's negative 3x plus 2x?
Negative x.
Negative x. So negative 3 plus 2, yeah, negative 1x. And now we got to get the 5 on the other side.
Negative 1.
So 4 minus 5 is negative 1. Okay, what's one way that we can solve a quadratic if the numbers work out nice?
Factor.
We can try to factor it. I'm not sure that's going to work. So we could try 3x and x. And then what do your signs have to be?
Both. A negative and a positive.
Has to be one of each, so we get a product that's negative, but I don't think it's going to work here. So we could try positive and negative, and then two numbers that multiply to give me 1.
1 and negative 1.
1 and negative 1. But that's not going to work, because when you multiply it out, that's negative 3x plus 1x.
Yeah.
That's not negative x. So this isn't factorable.
So you have to use the quadratic.
Can't do that. Got to use quadratic formula, which could happen on the test. Okay. What's A?
3. 3.
Yep. B
Negative 1.
and C.
Negative 1.
Okay. So we're gonna get negative B plus or minus. What comes under the square root?
3 squared. Right?
So it's going to be negative
It's-
plus or minus
it's
the
1
square root
squared.
of b squared.
Negative. Yeah, negative 1.
Negative 1 squared. So b squared, and then minus
4.
4, yep,
Times AC.
times AC. So that's 3, negative 1. And then divided by
Divided by
2
2 times A.
6.
So now just simplify what we have left, and that's our answer. So 1 plus or minus. Well, negative 1 squared, that's 1. And you're subtracting a negative. So what's that going to turn into?
A negative times a what?
Well, you're going to be subtracting a negative number. So that's going to turn into plus. So we're going to have 1 plus, what's 4 times 3 times 1?
7.
12.
Or no, 12. Yeah.
12. And 1 plus 12 gives me
13.
13. That is your answer. The only thing you want to do is make sure that that doesn't cause you to divide by 0. Well, if you go back up, what number would you have to fill in right there to divide by
Negative
0?
2.
That's not negative 2. How about right here?
1.
1. Well, that's not 1 either. So those are okay. There'll be a couple similar to that. Any question on that one?
That would make sense.
Okay. All right, so this one is a little more complicated because it's got a cubic in the top. When we deal with ones that are cubics or higher, it's usually going to say to solve graphically. So first, before we type it in though, what's the degree of the top?
The highest, like exponent? 3.
3. What's the degree of the bottom? 1. What's that a difference of?
Square.
Squared, or 2. And when you graph something that's squared, what is the shape of it?
It's like
A U.
S.
Like the U shape, right? Parabola. So when you zoom out enough on this graph, it should have that shape to it. So if we don't see that shape, we haven't zoomed out enough. That's important to keep in mind for the test. All right, let's type it in. When I type it in, what symbols do I have to make sure that I use? Because the numerator and denominator are kind of complicated.
Parentheses.
Yes, got to use parentheses. So x cubed plus 2x plus 1. We're going to divide by x plus 1. I'm going to start with zoom 6, and I'm going to see how it looks. I also need to set this equal to something. I'll set it equal to a number in a minute. But first of all, are you seeing a parabola shape here?
No.
Not the whole shape. I'm seeing part of it. The other part must continue somewhere. So what I'm going to do is set my y max. I'm just going to try 50. See if that does it. There you go. There's the other part to the parabola. So I know it's broken in the middle, but do you see how there is a parabola shape to it? Okay.
I think I got it.
How did you know it was going to be like up? You had to make the y max more instead of just making the x max or something like that. It's just kind of like it's just normally up top.
Because when I looked at Zoom 6, I could see the right side of the parabola. So I know there has to be a left side.
Yep.
Well, the left side isn't going to be further to the right.
Yep.
The left side, let's just look at that one. Okay, the left side, it's got to be somewhere like if this were to continue, it's got to be there. So since I didn't see it, it's not on the screen there. You're all set?
Yeah.
Yeah, thank you. Have a good night. Since I can't see it, I know it's going to be up there somewhere because that's where the parabola shape would go. So I knew to set my y max higher. That's how I knew. All right, so now let's set that equal to something so we can solve it. Let's do like equals, I don't know, 5. So how would I put in a line at 5 so I could find out where it hits 5?
You just go to the y2 and just put 5.
Yeah, just put in 5. Now, I'm zoomed back in again, but I can zoom back out. But to answer that question, I don't need to zoom back out. I am going to zoom back out to answer the next question. Basically, my line is right here. 5 is never going to hit that other part. I know that because it was off the screen. So that's up at like 20 or something. That's up too high. So I just have to see where they cross, and that's my answer. Yeah, now what if I just asked you, what if I gave you choices? Like I said, there's 3 choices. Is the answer between, let's say, is the answer between 1 and 2? Is it between 2 and 3? Or is it between 3 and 4? What do you think? I know it's kind of hard. I don't even know if I drew that accurately.
Probably between 2 and 4.
Yeah, let's see. I might have to add another choice. Let's find. Actually, no, that graph is accurate.
1, 2, 3.
Yeah.
Looks like it's between 4 and 5.
Look at that one.
Which one?
1,
Oh,
2,
that
4, 5. It looks easy.
Well, I know it's at a height of 5 because that's where my line is. But the answer is
Oh,
you're solving for the
like
x.
between 2 and 3.
Yeah.
Yeah.
I think it's going to be in between 2 and 3. So what I might do is just ask you that. I may not even ask for the exact answer. I might just say, what is it between? And in this case, you would choose B. It's between 2 and 3. All right, so the answer there would be B. Now, if I asked you how many local minimums does that graph have? If you look at that screen, how many would you say?
0.
You'd say 0. But we know if you zoom out enough, it should look like a parabola. And you do have a local minimum. It's off the screen. Most people miss the one that's off the screen. Right? You just have to zoom out. Right? So now, how many local minimums does that have?
1.
Just 1. Yep. And it's right there. So the point is always zoom out enough so you can see if there's a local minimum. All right. Now, is there any question how I got that exact answer? You all set?
Yeah, do you want my scrap paper? Or just go away?
No, that's okay. You submitted it?
Yeah, I did.
Perfect. You're all set.
Have a good day.
Yep, you too. Is there any question how I got that intersect? In case I asked for the exact answer and not like what it's between. I think I do both.
So if you ask it between, are you gonna put it like that in like parentheses?
Yeah, yeah.
Okay.
This is like the low value and then the high value.
Okay.
It's an interval between 2 and 3. You guys are okay with the intersect?
Yeah.
Okay. So we got that. Take a look. So here's another rational equation. It is a little bit simpler than this one, because this one had 3 separate fractions to it. This one only has 1. That's it, just 1. So we want to get rid of this x minus 4. What would you multiply the left side and the right side by?
X minus 4.
Just x minus 4. When you do that on the left, what's going to cancel?
The X minus 1.
Yep, that's gone. And on the right, what cancels?
Nothing.
Nothing. There is nothing to cancel.
So
So now we're left with x plus 3. And 5 has to be distributed.
So 5x minus 20.
And now we just get x by itself. So if we minus x from both sides, what's 5x minus 1x?
Negative 4x. Oh, 5x minus. Never
Yeah,
mind.
5 minus 1.
Is 4x.
4x, yep. And now what could we do with the 20?
Add the 20.
Yeah, we could add the 20 to the other side. So now we get 23 equals 4x
And then divide by 4.
and divide by 4. And the answer is 23/4. Now the only number that you cannot plug into the bottom here
Is 4.
is 4. That's not 4, so it's fine.
Okay.
Any question on that?
If you can't plug it into the bottom, it's just like an imaginary number then? Or it's
Extraneous
not-
solution.
It's extraneous, okay.
Yeah. So if you ended up with 4 as the answer, you would say it was extraneous.
Okay.